All right, this is a short video on transformations of cubic functions. Now, before we go to transformations, let's just review quickly the parent function for cubics. All cubic functions, including the parent, have a point of inflection. On the parent, that happens to be at the origin, 0, 0. The point of inflection is right in the middle of your graph, and it's right in the middle of the little squiggly that you see. It is the point where the graph changes direction. The domain and range for the cubic parent function are always all real numbers. The x and y intercept for the parent function are both 0, 0. And of course, this graph is increasing as x increases, so does y, going to infinity. So now let's take a look at what changes to the parent function in terms of the transformations we see in A, C, and D due to the graph of the function. Now, this is a good place to pause and take lots of notes. It's a great review of transformations in general and transformations of cubic functions specifically. So let's start with the parameter D. D shifts your parent function up or down D units. Next, let's take a look at C. If you have x minus some C value, then it is shifting it to the right C units. If you have x plus some C value cubed, then it is shifting it to the left 3 units. Now, the parameter A actually can do 3 things. If A is negative, then it's a vertical reflection. It flips your graph up or down. If A is greater than 1, then it is stretching your graph vertically, otherwise known as a vertical reflection. Now, if the absolute value of A is a fraction or a decimal between 0 and 1, like 2/3 or 0.527, then it is a vertical compression. So now make sure you pause and take great notes on this. All right, so let's take another look at A. Now, the blue graph here is the parent function, and the green graph is what the graph looks like if we have done a vertical reflection. In other words, we have a negative A value of -1. Now, here is what it looks like if you have a vertical stretch or compression. The blue graph, again, is the parent function. Now, the red graph is the parent function. If we change the A value to 9, then you can see that we have a vertical stretch by a factor of 9. It's very important to include what the factor of the stretch or compression. So this blue graph made it more narrow, or did a vertical stretch by a factor of 9. And then you can see if we make our A value a fraction between the values of 0 and 1, that it compresses the graph, almost like you sat on the graph and made it flatter by a factor of 1/100. These are great examples to write down and make a sketch of. Now, let's look at horizontal translations left to right. So in the red graph, that is our trusty, dusty parent function. In the blue graph, we have subtracted 2 from x, so that is going to move it to the right 2. The green graph, on the other hand, we've added 3 to x before we cubed it, and it's moving it to the left 3 units. Now you can see in all 3 cases, nothing happened to the domain and range, nothing happened to the shape, it just shifted left or right C units. Now, last, let's look at D, maybe the easiest transformation of all. In this case, the parent function is the red graph. If we want to shift it up 2 units, then we just add 2. And if we want to shift it down 1 unit, then we just subtract 1. Very easy. Now, what do you think this graph would look like? We have -4. So A has a value of -4. What do you think is going to happen? Well, let's take a look at the graphs. Oh, the green graph is our parent function, and it looks like we did reflect it. We did a vertical reflection, and it got skinnier by a factor of 4. Oh, in this case, all we did was add 1 to the parent function. What do you think's going to happen? If you said it's going to be shifted up 1, then you are completely right. Now, this does change the inflection point, but it really doesn't change the shape or domain and range or anything else. Oh, let's take a look. We have a D value of 8. We have subtracted 8 from the parent function. So if you said it's going to be shifted down 8, you are completely right. And it did change our inflection point, but it doesn't change anything else. Okay. So we have x minus 2 cubed. Now, if you're taking a look at your notes, you know that means it's going to shift it to the right 2. So if you said that, you are correct. Now, it doesn't change domain and range, but it does change our inflection point. Now our inflection point is at 2, 0 instead of 0, 0. And it changes our y-intercept. All right, so you probably got the hang of this by now. You know this is shifting it to the left 1, and it's going to change our inflection point in our x and y intercepts. Ignore this. That's the end of this. I hope you took good notes and that you understand transformations.